Okay, welcome. We're talking about logs because we have a test on logs tomorrow. It's not really very deep into logs compared to what you can go, but it's our hardest test on logs we've had so far. Let's just go back to the beginning. Why do we have logs in the first place? Because you can't solve this unless you graph it. Graph both sides and see where you cross. That pretty much solves any problem that's an equation. I want you to remember that because you're going to get to pre-calc and be like, how am I going to solve this? And if you just remember those words, graph both sides, see where they cross, it'll solve a lot of problems. But anyway, this one, other than that, we don't have a way of getting that x out of the exponent. And so we have logs. And what we do is log, and we say the base, which in this case the base is 5, of, and then we go over here, 7, is equal to, we come back here, x. And then not because that can be calculated. Grab your graphing calculator, type that in, round it to 3 decimal places, billboard it to me. Let me make sure you know how to put that in. I'm going to pause for a second while you do. What I hope you typed in was log 7 over log 5, and you got 1 point something. One of the easiest questions on the test would be, what is this answer between? And you say it's between 1 and 2 because you know it's 1 point something, right? So, well, actually, 3 decimal places, 1 point what? 209. All right, and you don't need to billboard that to me. I'll have you billboard the next one to me. Okay, so this could have been done with ln. Just double check for yourself. If you've done ln 7 over ln 5, make sure it really comes out to 1.209. Because what you're doing is you're using numbers that have a smaller base, and therefore they're actually bigger numbers. But they're both bigger numbers. So when you divide them, ln 7 divided by ln 5, they're both bigger numbers. When they divide out, they should still be 1.209. Right? Check it? Okay, good. Okay, next thing. These get much more complicated because you go like this. Okay, so how would you start a problem like this? The first thing you would do is not rewrite it, because this has already got the x over here. It's almost alone. All I really have to do is figure out what all this is and then divide it by 5. Do you get what I'm saying? The x is almost alone already. So on this kind, you would not rewrite, but you would try to figure out this. And then it would be helpful to know that this could be written as a 1/16. We rewrite as 4 as a 1/16. 1/16 to the negative makes it, wait, not negative. Wait. Negative, no, negative 1/2. There we go. I thought it wasn't negative for a second, but it is negative. What I'm trying to do there is replace this with a 4. So I want to double check. Is that really equal to a 4? 1/2 means the square root. Square root of 16 is 4. And then the negative makes it flip. So instead of 1/4, it would be 4. So yeah, that's. Why was that good? Because now this whole thing right here can be replaced with something really simple. A negative 1/2. So I'm going to go 3 times, again, this whole thing here is now negative 1/2. And that equals 5x. And now I'm going to multiply here, and I get negative 3/2 equals 5x. And then I'm going to, instead of dividing 5 and I get this fraction and a fraction, I what? 1/5 is correct. And then this 5 cancels this 5. My x is alone, and there's my answer, negative 3 over 10. Okay, that's about as bad as it would be if there was no calculators allowed. Now, if there's calculators allowed, then it wouldn't matter how ugly these numbers are. You just type them in the calculator, get the answer, times it by 3. And then to finish it, you'd have to divide by 5 to get rid of that 5. All right, so the newest stuff, the stuff that's like should be the hardest stuff for you, is the ln stuff. First of all, graph of log looks like this. Generally speaking, logs graphs look like that. And it depends on which one you're talking about. That would more like equals ln x. That means log base e. One of the first things I told you is ln, and you can replace it with log base e. All right, that's base e. Plain old log. If I write y equals log x, that means a base 10. Because I didn't say a base, you assume 10. That one's much more steep. It goes like that. All right, now log, a tree is really just a log. No, a log is really just a tree that's been blown over in the wind. It's sort of like it was really windy, see? And these got blown over. Anyway, those are log graphs. I just want you from getting them confused with these, which are exponential graphs. And we did do those before too. Okay, so the logs are the ones that look like they have roots here in the, and they're like trees that have blown over. They're logs. Okay, moving on. If I had this, y equals ln of x minus 4, take a wild guess where this has been moved. Right 4. Good. How about now? Down 3. Good. Okay. How about, some of the patterns that we have to know. These have to be like the back of your hand. What's it? 3. What's the answer? 3. Why? Because ln is really log based. Same. Answer's there. How about this? Not 1. 0. Really, what's happening is this is base 10, and you could say equals x, and you could say 10 x has to equal. And how is that possible? Only if x is 0. So the answer to any one that has a 1 right here, the answer will always be 0. Okay, next kind. What's that answer? 10. These two are the same, and that's the answer. I can show you the long way. X here. You go log, and then you say, what's the base? 8. And then you always go to the x is equal to, then you always come back, log base 8 of 10. And if you think about it, if those two bases are the same, then this has to equal that. All right. And the next kind. It's not what? It doesn't work. Why doesn't it work? Because you can't have a negative down here and you can't have a negative down there or up there. So that one is called undefined. Very good. It's not extraneous. That would be and it was an answer. Okay, I'm gonna pause for a second. Ooh. Back with you. All right. I guess that's most of the patterns that you're going to need to know. I think we studied for this a fair amount by just getting ready for the last quiz, and we just added a couple more topics here. So as long as you understand the most recent topics, which are basically the graphing stuff, moving graphs around. I guess let's do one more hard graph. Let's say you had an XY chart and you were asked to graph log base 3 of x minus 4, or 2x minus 4. How about that? If you're asked to graph this, my advice to you is to just go with the XY chart and find points and then graph those points. Because if you try to do this as, oh, I know log 3 kind of looks like, or log base 3 looks like this, and now I'm going to try to stretch it and move it, those get really complicated. It's true that this is half as wide, and it is moved to the right 4 places. So if I want to generally know what it looks like, that's fine. Generally, it's going to be to the right and skinnier. So I'm going to move it to the right and make it skinnier. Okay, but that is not going to be accurate. And if this is a graphing test, that's a good sketch, but it's not a graph. To graph it, you're going to want to pick points. And I want you to try this right now. I want you to tell me just random things. If you pick like 1, real nice. Okay. Think of what you should pick for X. Think of what number should go in there to make this work nice. And find me a few points. Put them on your iPad. I expect you to find 3 points. Anytime you're given a graph, you have to graph at least 3 points. Because 2 points only defines where a straight line is. If you've got 3 points and they go like boom, 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 you can kind of see where the line's going. See where the log is. So graph me 3 points. Find me 3 points. XY chart. I'm gonna pause while you do. All right, so listen up. Here's how you'd start this. I don't actually recommend 1. I told you don't just pick a number like 1 and then try it, because it won't work out real nice. Think about it this way. I'm going to scribble this out here. What number would be good to have right here in there? Underneath the blue thing, what if I had a 3 there? Do you think that log base 3 of 3 would be easy to get? See what I mean? So wouldn't it nice to have this be a 3 right there? So then what you say to yourself is, how can I get a 3 to be right there? I would need 2x minus 4 to equal 3. How could I get that? Well, use portable. 2x equals 7. X equals 7 halves. 7 halves is a good thing to... 7 halves will give you what? 7 halves will make this turn into 3. And then the whole answer will be log base 3 of 3, which is 1. So 7 over 2 comma 1 is a good combo. See what I just did there? I'll give you another one like that. Let's say I put right in here, if I could make that be a 9, do you see how that would be good? So I could say 2x minus 4 has to equal 9. Set this. Why do I want that to be 9? Because if I had 3 of 9, pretty good. Because then the 9 would just be 3 squared, and the answer would be 2. So I'm going to figure out how to make it 9. I'm going to add 4 to both sides. 2x equals 9 and 4 makes 13, so x equals 13 halves. So yes, you can put a decimal for that. But 13 halves goes with, that would make it into a 9. And then 3 of 9, which would... Raise your hand if you had some of those points. Okay, good. Then you guys are the ones that are going to pass the graphing part of the test. All right, I'm going to show you one more time, like one more problem like this, because I could sense a lot of you were not following it. So, y equals log base 4 of 2x minus 7. How do I graph that? Well, I want in here to equal 4. Do you get why I want that to come out to a 4? Because if there was a 4 right here, then answer would be 1, right? So figure out, how can I make that equal 4? 2x minus 7 has to equal 4. Solve it. And then find me a couple other points. Now that we learned how to do it on the other one, should be okay at it on this one. Okay, so here's the points I would have gone with. I would have wanted to make this equal 4, because then it'll be log base 4 of 4, and that's equal 1. So that's simple. So, how do I make it equal 4? I'm going to add 1 to both sides, 11, and then I divide by 2, x equals 11 halves. And that means I put in 11 halves, and I will get out an answer of log base 4, which will be 1. Raise your hand if you had that point. Okay, good. Yes? No, when you graph these points, you would be done. So you'd have to find these spots, 5.5, comma 1, and you graph them and you're done. All right, so let's find another one. If I made this spot there equal to, it's another good thing. Why should I make the stuff in the circle equal 16? Because it'll be log base 4 of 16, and that's really 4 squared, so the answer would be 2. I know I'm going for an answer of 2. How do I get this to be 16 in here? I say 2x minus 7 equals 16. Add 7 to both sides. 2x equals 23. Then I get x equals 23 halves. It's another comp that would have worked. Another awesome one is if you this stuff equal 1. So how do I get 2x minus 7 to equal 1? I set a little equation like this. Add 7 to both sides. 2x equals 8. X equals 4. Yeah, that's a nice point. 4, comma, x when I make this equal 1 right here, if this thing equals 1, then the answer is automatically 0. Or comma 0. All right. Some examples. Now, if you get stuck on another one like this during this hour, feel free to ask me. I can show you one-on-one. Maybe that'll help. But this is something we learned the other day, graphing, and it is on this test. It's not a big, huge part of it, but it's part of it. All right, so now, what are you doing for the rest of the hour? 2 things. Number 1, we have a worksheet. I haven't posted it yet, though. Number 2, we have the... All right, sorry, I got distracted there. Number 2 thing is we have a Schoology quiz. So, in-class quiz. Right now, I have made it available already. If you go into Schoology, you go into tests. I know you're talking about math, but it's still distracting, so don't. Go into tests under Schoology. You'll find it there. It says logs practice test. I think I got all of the common, I think I got all the problems worked out so that there's not mistakes on it. There was a couple little things before, but I think it's all fixed. So you should be able to give it 2 shots. In fact, it's set to be able to let you do it once in class and then once again at home. Okay, so you don't have to do that tonight. It's optional, but if you want a better score on it, you can. Then the homework is kind of unusual because tonight I'm going to let you decide for yourself if you should do the homework. Okay? How should you decide that? If you've gotten A's on every test in the past that we've had, including this most recent test on logs, maybe you don't need to do it. Maybe you should just look at it and see if there's any that scare you. You want to practice that one. All right. So the answers and for the homework and the answers will be posted for tonight as something you optionally can do. Now the sad thing is that some of you will make the wrong choice. You're the kid who really should do the practice, but you won't because it's optional. But you have to make those decisions for yourself, whether or not you should do something, and then do it based on that. Okay, I'm leaving it optional. But the in-class Schoology quiz, not optional. Got to do it. Okay, so everybody right now, would you find your Schoology quiz? And I am also, in this case, going to let you work with a partner. So, if you would like to work together with somebody, get some paper so you can do the problems on paper. You know, that thin white stuff? Yes, you can actually write on paper and then take the quiz on the iPad. It's just nice to have them both up at the same time. If you'd rather use the 4-finger swipe and go back and forth and use remarks, you can do that. But a lot of kids preferred to use paper last